Now, in this next case, you've been told 120 students pursuing a course in electrical engineering were examined and their data results summarized as shown in this table. So you've been told this table constituted 120 students, isn't it? So these were their marks were given in form of classes. Are we together? Then you've been told to use an assumed mean of 55 to determine the minimum and the standard deviation. So we need to construct a table with how many values? 1, 2, 3, 4, 5, 6, 7, 8, 9. So those are 9 rows. Construct a table with 9 rows. A table with 9 rows. That is 1, 2, 3, 4, 5, 6, 7, 8, 9. So those are table with 9 rows, then the column of summation. So the first row here, we have the row for the marks, which are giving us the classes, isn't it? So the row for the marks is the classes. And those classes marks are from 20 to 29, then from 30 to 39, then 40 to 49, then 50 to 59, then 60 to 69, then 70 to 79, then 80 to 89, then 90 to 99. Then the number of students is giving us the frequencies, isn't it? So the frequencies you have 7, 12, 14, 28, 25, 14, 12, 8, isn't it? So from the classes, you are able to get the midpoints, the x, isn't it? You are able to get the midpoints there, the x. So what is the midpoint of 20 to 29? 24.5, isn't it? Yes. Are we together? Yes. We are getting x values, the midpoints. So this is 24.5. What is the midpoint of this class? The midpoint of 30 to 39? 30 plus 39 divided by 2, isn't it? You get 34.5, isn't it? What is the midpoint of 40 to 49? 44.5. It is 40 plus 49 divided by 2. Then what is the midpoint of 50 to 59? 54.5. The midpoint of 60 to 69? 64.5. The midpoint of 70 to 79? 74.5. The midpoint of 80 to 89? 84.5. The midpoint of 90 to 99? 94.5. And we've been told to use an assumed mean of 55, isn't it? So for us to use an assumed mean, we need a new data value d, isn't it? Meaning the new data value d will be x minus the assumed mean, isn't it? We need the new data value. It is the old data value minus what you are assuming, isn't it? So from here, what do? If you put a bar on top of d, then you put a bar on top of x. Then about 55, the mean of 55 will still be 55, isn't it? Are we together? So d is the old data values minus the assumed mean. So if you put bar in either case, you get d bar is equal to x bar minus 55. So from here, from d bar is equal to x bar minus 55, you are able to get the mean, the x bar, isn't it? So what is the mean? So you take 55 coming this side, x bar will be d bar plus 55. Are you seeing that? So our mean we are looking for x bar is going to be 55 plus d bar, and d bar is the mean of d, isn't it? So it means for us to get the mean of x using assumed mean, we must get the mean of d. Is that okay? So can we now first of all starting by getting the d value, the new variables using the assumed mean, isn't it? So the d value will be d minus 55. So the first it will be x minus 55, I mean. So x minus 55, 24.5 minus 55. It is x minus 55 because you'll be told to use an assumed mean of 55, isn't it? So for you to get the d values, it is x minus the assumed mean. Okay? Negative 30.5. Then the next 34.5 minus 55. Negative 20.5. Then the next 44.5 minus 55. Negative 10.5. Then the next 54.5 minus 55. Negative 0.5, isn't it? Then the next 64.5 minus 55, you get 9.5. You get 9.5. Then 74.5 minus 55. 19.5. Then 84.5 minus 55. 39.29. Yes. So you get 29.5. Then 94.5 minus 55. 39. So you found the d's. The d's are there. The x minus the assumed mean, isn't it? So after getting the d's, what do we want to get? For us to get the mean of x, we must get the mean of d. The mean of d is the expected value of d, isn't it? Meaning you are summing up all the d values, and when you are summing up all the d values, you must sum them with the number of times they are appearing, isn't it? Are we together? Then you divide by their total number n, isn't it? So what is n? N is when you sum up all the frequencies, summation f gives you n. When you sum up all the frequencies, gives you the total number. And I think you were told the total number was 120. If you add up all the frequencies, isn't it? You are supposed to get the total number n, meaning summation f is n, isn't it? So n is the same as, so here we have summation fd over n. N is the same as summation f, meaning if you sum up all the frequencies, you get n, isn't it? Yes. Good. So what do we get? What is n? 120, isn't it? Are we together? So for us to get the mean, we need a column of fd, isn't it? A column of fd. So can you put the column of fd? F times d, isn't it? So start multiplying f times d. So let's say this was the column of summation, meaning anything which will appear in this column is summation, isn't it? Are we together? So f times d, start with this. This is f is 7, d is negative 30.5, isn't it? You get? Negative 213.5. Then yeah, 12 times d times negative 20.5. Negative 246. Then the next one, 14 times negative 10.5. Negative 147. Then 28 times negative 0.5. Negative 14. Then 25 times 9.5. 237.5, isn't it? Then 14 times 19.5. 273. Then 12 times 29.5. 354. Then 8 times 39.5. 316. You are done, isn't it? So we want to sum all the FDs. So if you sum all the FDs, what do you get if you sum all of them? If you add all the FDs, this column is for summation. So when you sum up all the FDs, what do we have? You have? You know sum them. Add them. If you add up all the FDs, What do you get? $323. There we have 323. Anybody with a different value? That thing is more than 300. This will cancel with this will cancel with that thing is more than 300 by 5. It is? 560. 560. My friend, do the right summation. 560. So you just substitute the values. If you sum all the FDs, you found 560. Divide by their total number. If you sum all the F, you found is 120. So what is the mean of D? 560 divided by 120.
4.67.
4.67. You get 4.67. Are we together? So after you found the mean of D, it is now helping us to get the mean of X, because the mean of X is the mean mark of the data values, isn't it? Are we together? So the mean of X is what? Is the assumed mean plus the mean of, it is the assumed mean plus the mean of D, isn't it? Are we together? So assumed mean plus the mean of D, you get the mean of X to be 59.67. So the mean of X is the mean mark, because X were representing marks, isn't it? So the mean mark is 59.67. So we found the mean mark is 59.67. Now we want to get the standard deviation, isn't it? Are we together?
Yes.
So the standard deviation, what did we say? Standard deviation is the square root of the variance. So you start by getting, and we proved, you can remember we proved that the variance of X was the same as the variance of D, isn't it?
Yes.
The variance of X was the same as the variance of D if D was just X minus assumed, isn't it? But there are cases when D is X minus assumed over the class interval, then the variance of X will be I squared variance of D. But here we did not divide by the class interval. Are we together? It was just X minus assumed. And we proved that the variance of X was the same as the variance of D. Are we together? Are we together? Yes. So it means the moment you get the variance of D, you have found the variance of X. Senor, you have found the variance of X. So what is the variance of D? The variance we said is the expected value of D squared. And the expected value of D squared is the mean of D squared, isn't it? So the variance of D was the expected value of D squared minus the mean squared. The mean is the expected value of D, then squared, isn't it? Are we together? So the expected value of D squared is the mean of D squared, isn't it? The mean of D squared, it means you sum all the D squares and the number of times they appear, isn't it? Yeah. Then you divide by their total number. Then it is minus the mean squared. Isn't it? Are we together? So with this you would have found the mean of, you would have found the variance of D. And that variance of D is the same as variance of X. So for us to get to it, we already know N, we already know the mean of D. So what we need is a column of FD squared, isn't it? Yeah, so just like the other gentleman there introduced for us the best method to get it, for you to get FD squared is just FD times D, isn't it? Are we together? Yes. That is the best method. So FD times D gives you FD squared. So FD times D, negative 30.5 times negative 213.5. So that is FD times D to get FD squared. What do you get? Positive 6,511.75. Go to the next one. FD times D to give you FD squared. What do you have? 246 times 20.5 because negative times negative is positive. 50.43. Then next, F times D, 147 times 10.5. Those negative don't be there. Then because negative and negative is positive.
1543.5.
1543.5. Then go to the next one, F times D. What do you get?
7.
Go to the next one. FD times D, I mean. FD times D. You get FD squared.
22, 56.25.
22.
56.25.
56.225. Go on. FD times D, you get
53.5.
53.
23.5.
53.
53.23.
Or 53.23.
Yes.
0.5.
Yes.
Good. Go to the next one. FD times D to get FD squared.
1044.
1044. 3. Then the next one. FD times D to get FD squared.
1248.
10.
1248.
1248 2. Like that. So if you sum all these FD squares, if you sum all of them, what do you get? Sum all of them. If you sum all of them, what do we get? Add up all of them. What do you have?
43,610.
43,610. Good. So we have 43,610. So we've added up all of them. So the next thing we are doing is to substitute, isn't it? So here we found, when you sum all the FD squares, you found 43,610, then you divide by n. N you found is the sum of all f, which was 120, then minus the mean of d squared. The mean of d you found is 4. So the mean of d you found 4.67. So it is minus 4.67 squared, isn't it? Because it is the mean squared. So at the end, what do you get? What do you get? To be the variance of x. What do you get to be the variance of x? 43,610 divided by 120 minus 4.67 squared. We have the variance of x to be 341.61, isn't it? So the variance of x is 341.61 because remember we started from the variance of x and the variance of x was the same as the variance of d, meaning this variance of d we found is the variance of x. Are you getting the idea? Are we together?
Yes.
Good. So after getting the variance of x, we can now get the standard deviation. The standard deviation is the square root of the variance. So what do you get to be the standard deviation?
18.48.
18.48. And by that, you will have answered the question using the assumed mean approach, isn't it? Using an assumed mean approach. Let's see another case on the same